Okay, I'm not a huge fan of this first part here. It says name the property that each statement illustrates. So this is 1.4 or 1-4, whatever. So split it. And you're gonna have to take good notes because you're gonna have to look back at these when you do your assignment, when you do 1 through 6 on the back page. So it says 3/4 times 1 equals 3/4. Now anytime you multiply a number by 1, it can be a fraction, whatever, it just ends up as the exact same number as what you started with. Okay, that is known as the identity property of multiplication. You're going to want to listen to this because you're going to go back and look through these. Identity property, whenever you take something times 1, that's the identity property of multiplication. Now the next one, I have a number x. It doesn't matter, x is a variable, but it can be any number. It could be like 6. And I add 0 to it. Well, it just goes back again to the number that you started with. So when it goes back to what I started with, but this is the identity property of addition. So whenever it goes back to what you started with, it's identity property, multiplication, addition. Okay, next property, it says 3 plus 5 equals 5 plus 3. Now 3 plus 5 is 8, 5 plus 3 is 8. So the order of addition doesn't matter, okay? All they did was switch the order, but they're equal. That is known as the commutative, I don't care about spelling, commutative property of addition. So whenever the order's just switched, it's a commutative property of addition. Now the next thing you're going to see, 8 times -1 equals -8. Now 8 times 1's 8, and if I take 8 times -1, then the answer is just negative, okay? That is known as the multiplication rule of -1. Okay, that's all you need to do. When you take a number times -1, it just takes that number and switches the sign from a positive to a negative. Multiplication rule of -1. Okay, now we see parentheses. 5 plus 3 plus 4 equals 5 plus 3 plus 4. Now let's examine. I would do the parentheses first, that's 8, and then plus 4 is 12. Now over here I do the parentheses first, 3 plus 4 is 7, 5 plus 7 is 12. So they're both 12. All that changed is that the parentheses was moved, it was shifted. Whenever you see a shift in parentheses, that's called the associative property. And this is the associative property of addition, because we see addition signs. Okay, next problem. We see almost the same thing. 2 times 4 in parentheses times 3 equals 2 times 4 times 3. So 2 times 4 is 8, and then 8 times 3 is 24. 4 times 3 is 12, and 2 times 12 is 24, so they're equal. And all that's happened, like on this problem, is the parentheses have shifted around. That's known again as the associative property, but instead of addition, it's multiplication. Yeah, I have to watch this dumb cat here. My parents are away right now. They gave me this cat that I had to sit. It's pretty annoying. It's not my cat, by the way. Okay. All right. 5 times x equals x times 5. Now again, it's like this. The only thing that's changed from this, and x can be any number. X could be 2. 5 times 2 is 10. 2 times 5 is 10. The only thing they changed is the order they put in. So it's commutative property, but instead of addition, it's a multiplication. Okay, and then the last one, 89 times 0 equals 0. Well, whenever you take any number times 0, the product goes to 0. So it's like this, but instead of the multiplication rule of -1, it's the multiplication rule of 0. So those are your 8 properties. Hope you took good notes. They're going to have 6 of them on the side. They're almost the exact same, just with different numbers. Okay, so there's that part. Okay, then the next part, they give you expressions to simplify. Okay. Okay, your job here is to simplify. And here's what they mean by this. You don't put anything in for x, you just leave it. Okay, the variables in this part of the assignment, you just leave there. You don't put anything in for it. What you need to do first is make sure there's an operation sign between each of your numbers and variables. Okay, so between 2 and 5 we have plus. Between 5 and x we're going to put a multiplication dot. X and 7 we have plus. So here's how we're going to handle this. We got 3 numbers that we see. Okay, the one that's being multiplied by x, we need to just drop that down. Okay, and that's done. Now the remaining 2 numbers you can add. 2 plus 7 is 9, so 5 dot x plus 9. Eliminate the times dot, and it's 5x plus 9. That's your answer. Okay, it's all you do. You can't add the 5 and the 9 because 5 is when one of the numbers is multiplied by a letter and the other one isn't, that can't be added. Okay, so that's how you execute that. Next one we got 8, 3x. So between 8 and 3 we have times, 3 and x we have times, so it's all times. Now what I'm allowed to do when it's all times, I don't have any pluses to worry about like I did over here. When all I have is times, I'm allowed to multiply the 2 numbers. 8 times 3 is 24, and then we keep the dot x, but then in the final answer we just remove the dot and it's 24x. Okay. And you're going to have some repeats, so basically the same procedure. 8 and 3 is a plus, 3 and x is times. So we have the times, we also have addition. So look at the number being multiplied by the letter, that just drops down. Done. You should always do this when adding, drop that down. The number's not multiplied by letters, the 8 and the 100, we can add those and that's 108. Now remove the dot, 3x plus 108. Really not too hard. Okay, 4 and then 3b. So 4 and 3, that's multiply, 3 and b is multiply. So when it's all multiplication with no addition, we're allowed to multiply the numbers. Okay, 4 times 3 is 12 times b. And it all goes back, I don't want to tie it too much into the properties, but it all goes back to the multiplication property, the associative property. It doesn't matter the order you multiply. If you have 3 things, 3 factors, 4, 3, and b, you can multiply them in any order you want. Okay, so 4 times 3, I know that's 12, but I don't know what b is, so 12 times, oops, right, 12b. Okay. All right, next one. 3 times x times 12. And then, so the dots are already there, okay? So again, if it's all multiplication, we can multiply the known factors. 3 times 12 is 36 times our factor of x. So it's 36x. Okay, next one, I got 2.3 plus 3p plus 0.5. So between the 2.3 and the 3 is a plus, the 3 and the p would be a multiplying, and then p and 0.5 is plus. So the pluses, well, the number being multiplied by the variable, we don't know what the variable is, so we just drop that down. Okay, cross it out. And then we add the two known numbers because they're not multiplied by variables. So 2.3 plus 0.5 is 2.8. Okay, now a little bit different here. 8ab divided by a. So times dot, a on the bottom. So we can't really multiply anything because I know that 8's a known factor, but a and b are variables, so I'm not going to really multiply. But I'm dividing by a, so what I'm allowed to do, I have a factor of a on top divided by a factor of a on the bottom. Now in division you can cross those out, and we have 8 times b. You can write that as 8b. Okay, and then the other ones go the same way. So we have 25 times x times y. Can't multiply anything because we don't know what x and y are. Well, we know y is on the bottom. I have a y divided by a y, so those cancel out. We have 25 times x. That's how you divide variables. So 25x. Okay. 8x divided by xy. So that's a times, we have division. Okay, so I can't multiply, nothing, okay. X's can cancel, but I still got y, but it's not 8 times y anymore, okay. You got to put 8 divided by y. The line has to be there. Okay, then the last one, 40ab divided by 4a. So times. Okay, now I can't times anything on top or on bottom, but I can cancel the a's, and I can also, listen to this now, okay, I can also divide 40 by 4, okay, because I know 40, I know 4. 40 divided by 4 is 10, okay. When you do that, you cross out the bottom factor and just change that to a 10, okay. So if you have one known factor on top, one known factor on bottom, you're allowed to divide 40 by 4. Cross out the factor on the bottom and then just change the top to what the quotient was, which was 10 times b. I don't have anything on bottom, so I don't need the line. See, here I had to put the line in my answer because there's still a y on the bottom, but here 10 times b, right, is 10b. Okay, now in this last part, this third and final part, I'm going to use 2 boxes for each problem, okay? Tell whether the expressions are equivalent. 3 plus a plus 10, 3 times a times 10. Here's what I would do. Replace each variable with a number, just let's use 2. Do it on the assignment, 2. So it's going to be 3 plus 2 plus 10, 3 times 2 times 10. Then do your PEMDAS, no parentheses, no exponents, no multiplying, so it's just adding. So that's 15. Now is this 15? No parentheses, no exponents. Multiplication, yeah, 2 of them. So 3 times 2 is 6, 6 times 10 is 60. So no, you write not equivalent. That's the answer, okay? That's the best way to do those problems. 3x times 0, and then just 1. So 1's pretty well done. Now let's say x equals 2. So 3, remember it's times 2, so it's not 32 times 0. Parentheses, no. Exponents, no. Multiplication, yeah, it's all multiplication. I wrote that wrong. So that's 0. Whenever 0 is a factor, it's 0. Well, they're not equivalent. Okay, next problem. 4m and then 4m times 1. M is 2. Okay, so 4 times 2, that's 8. I don't need to make the list when it's just one operation. M is 2, so 4 times 2 times 1. Multiplication, yeah, it's all, so that's 8, so these are equivalent. Again, best way to see if two expressions are equivalent is just replace the variables with a number. We're going to use 2. Use 2 on the assignment too. X, 5 minus 5, and then 1. So x is 2. So 2. Again, it's a variable. I can use 5. I can use 10. I can use whatever. 5 minus 5. So we have to do the parentheses first. That's 0. So 2 times 0. Remember, it's not 20. It's 2 times 0. That's 0. 0 and 1, not equivalent. Okay. Next one, we have 8 minus 3 times pi, and then pi plus 5. Now, if you see pi, don't use 2. Pi rounded. Remember, it's irrational. It goes on forever. We're going to use 3.14. So 8 minus 3 times 3.14. And then over here, 3.14 plus 5. Parentheses, 8 minus 3 is 5. And I'm going to take my calculator and multiply 5 times 3.14, 15.7. If I add these two, it's going to be 8.14, so not equivalent. Equivalent means equals. It's another thing to know. Okay, pretty easy really if you know how to do the order. 4 plus 6 in parentheses plus x. And then x plus 10. I'm going to put 2 in for x. Okay. So 4 plus 6 plus 2. And you can put in any number. It doesn't matter. You can put 20 in for x. Just use the same number. Okay, so that's 10. 10 plus 2 is 12. And that's 12 as well, so we have an equivalent. Okay, next one. 25xy over 5x, 5y. Okay, this time we have an x and a y, so let's put 2 in for x, let's put 3 in for y. It doesn't matter what number you use. So 25 times 2 times 3, 5 times 2. And this here, 5, that's a y, so we want to put 3 in for it. Parentheses. Remember, when you have more than one on a division line, if you have more than one number on top, parentheses. Same on bottom. So do your parentheses first. 25 times 2 times 3, so it's all multiplying. 50. 25 times 2 is 50. 50 times 3 is 150. 5 times 2 is 10. So what's 150 divided by 10? Well, you can cross out the zeros and it's 15. You can use a calc. 5 times 3 is 15, so those are equivalent. Now don't do this, but just watch, okay? You could have also, without plugging numbers in, you could have done this problem without putting numbers in, because if you put operation signs, we know we can cross out the factors of x on a division problem. We also have these two known factors. 25 divided by 5 is 5, so I cross the bottom out and that top, and we have 5 times y, which is what we have here. All right, one more. $12x, and then parentheses 2 plus 5 minus 5, 5y. Let's go 2 for x and 3 for y. So 12 times 2 on top, then the bottom 2 plus 5 minus 5. We got two numbers on top, put a parentheses. And over here 5, remember that's a y, so make sure you're putting the 3, not the 2. Or wait a second, I messed that up. It was 6x, 6x. I was on the problem above. So 6 times 2. Well, we know that's 12. 24 divided times 2 is 20. 12 times 2 is 24. Then 2 plus 5 is 7. 7 minus 5 is going to be 2. 24 divided by 2 is also 12. Okay, so those are equivalent. Okay, then the last one. 7p 2 plus 1 minus the square root of 4. That's 7p. Let's put 2 in for p. So we have 7 times 2. 2 plus 1 minus the square root of 4. And 7 times 2. Well, we know that's 14. Now let's set up our PEMDAS on the other one. Parentheses, yeah, because top and bottom. Okay, now 7 times 2 is 14. Easy enough. Okay. Now, in this parentheses, what do we do first? Well, the square root acts as an exponent. Okay, you got to figure out the square root of 4 first. What times itself is 4? Well, it's 2. So you can cross that out and put 2. You do the square root like an exponent. And there's no multiplying and dividing, just addition and subtraction. So 2 plus 1 is 3. 3 minus 2 is 1. 14 divided by 1 is 14. 14 and 14, those are equivalent. Again, remember on those fractions, when you have more than one number on top, and it doesn't matter what the operations are going on, you need to put those in parentheses, okay? And then follow your PEMDAS to get what it's equal to.